Hello, everyone. How are we doing? How is everybody? Oop, I'm showing my backdrop. Hello. Hey, Sarah. Hey, David. Hi, Casey, Jim, Nikolai, Martin, Jonathan, Thomas. Hey. Hi, AM. Good. Happy to be here on this, what day is it? Tuesday? Tuesday. Uh, solve some puzzles. We're gonna start, uh, oh, is there a cracking the cryptic stream today? I didn't even know. What is it? Chance of Sinar. Huh. Who knew? Um, well, so that's a good question. Do I do my normal stream or do I stop uh when cracking the cryptic starts? What do we all think? Let's let's see. I mean, I'm probably not going to mod today, so I will just be here. Uh yeah. Looks like people want me to keep streaming, so that's what I'm gonna do. Uh I didn't know about the stream. Uh I have a work meeting at my other job tonight, so uh yeah. So we're just going to do our normal thing. Okay. This is an older. I'm cold now. My heater on. Even though it's warm outside, it's like 60 degrees. Which is, I don't know, 18, I think, for people who use Celsius, something like that. Uh, hey, Jay Dyer. Uh, this is an older puzzle. I think this is from back in May, but it's been hanging out in the bucket, and I'm a fan of James, so let's do this. Let's turn off row and column labels, shall we? Since we have uh, outside clues. Okay. This is a Fog of War puzzle, and it's also a Wrogn puzzle, where every clue is Wrogn. And as people are saying, Zach is getting ready. So But just to go over it, clues outside the grid must not give the sum of the diagonal. Digits within a cage. Digits within a cage still can't repeat, but they must not. Oh, wait. They could repeat. It's just that they can't be a non-repeating set of digits that add to the given total. So then we have arrows that must not be normal arrows. Thermos must not be normal thermos. Green lines have to have at least one pair of adjacent digits that differ by less than 5. Orange lines have to have at least one pair that differs less than 4. The 4 cells surrounding a one of these white circles must not contain all of the digits inside that circle. Digits in a shaded circle must not be odd. Digits on a V must not sum to 5. Digits on an X must not sum to 10. Digits on cells separated by a white dot must not be consecutive. Cells separated by a black dot must not be in a 1-to-2 ratio. And that is all the rules. We are going to, and yes, I see chat and I take your point. We're going to place a bet tree down here. And I will get betting started, and then we will place the 4. Okay, there's betting. This is a quad with a 4, so no 4 can go in these cells. This is a quad with a 4, so no 4 can go in these cells. Now, this cell has to be even, so it could have a 4, except that this 4 diagonal means that this can't sum to 4. This can't be a 4. So 4 can only go here, and as predicted, we get to bring in Zach for a 4 dance. Woo! Woo! Boop, boop. Thank you, Zach. Thank you. Whoops. Zach just fell off the table and ran away to a corner. All right. I'm very, not centered today. There we go. Hey, Helioplix. So yeah, as Kyle says, these are both even, but they're not 4 and they're not 6. So they are 2 and 8. Yes. Oh, hey, Rangsk. So, let's see. People are saying this is a naked single. Okay. It's right. So it's not consecutive with 2 or 8, and it's not anything. So it's not 1, it's not 3, because of the 2. It's not 4 because there is a 4. It could be a 5. It's not 6 because of the quad, And it's not 7, 8, or 9 because of this. So it is a 5. And now... Okay, I was thinking of where does 6 go in the box, but... That is cute. Are we allowed to read the 6 on the lower quad? And I think we are. There is a 6 in this quad that is sort of readable. Nikolai is catching us that they could have a 6 as long as they don't have a 9. So, thank you, Nikolai. We almost made fools of ourselves. Let's see, what have we got? Huh. Hi, Amy. I agree with Jay that this isn't a -4, or it would make this one clue correct. So that's something we need to keep in mind. Actually, this has a white dot relationship with this, so it's actually very limited. It can't be 1 or 3, or 4, or 5, or 6. Wait. What is this? Oh no, it could be 1 if... Right. This is... We don't know what this is. Right. It could be 1 or 3. So this is 1, 3, 7, or 9. And it's going to... And whatever this is will knock out a bunch of it. Yeah. Yeah. People are... People are correct there. Zeta Math, I don't see why you can't put a -4 on a 4 quad. They're not the same number. Yeah, and we have the same relationship here. How are you, Zeta? Did you survive your morning meeting? Ah, Jay Dyer pointing out that since we don't have a total in this cage, we need a repeated digit. And it's not 2 by this black dot. It's not 3 by this white dot. It's not 4. It's not 5. It could have been 1. It could be 6. Could be 7 or 9. Not 8 because of this black dot. But these are definitely... Oh, good point. Because these thermos go the... That's a great point to... a bunch of people are seeing this. Is that because of these little thermos, it can't be 1 or 9, or at least one of these thermos would be correct. So it's not 1 or 9, it's 6 or 7 only. Oh, And Garion has the rest. If it were 6, you couldn't put 6 in box 1. So these are 7. Very nice. So no 7 there. Ah, and now we have to place that digit in box 1 so it goes there, which is going to resolve the 2-8 pair. So that's not a 9 anymore. Right, this needs to be bigger than this, and it can't be an 8, so it's a 9. So we absolutely could put a 6 now on this dot. No, we can't put a 6. What am I saying? We now can't put a 6. It's the opposite. So 6 must go here. So that means this has to be a 1. Yeah. Yeah, I had it completely backwards. And what's left in this box? We need a 3 and we need 9. So they go in this order. Okay, so this isn't. It could be 1. No, it can't be 1 by the circle. It can't be 2, can't be 3, can't be 4 by the X, can't be 5, can't be 6. So it's 8. It must be 8. The whisper isn't true yet because we don't know what this digit is. So this digit is going to have to be, oh, is this digit just an 8? No, it could be a 5. It's a 5 or an 8. Oh, it's not an 8. It is a 5. That's the only way we make this whisper wrong and this dot wrong. Okay, so this needs to be within 5, within 4 of 8. So 4 is the minimum it can be. Can't be 5, 6. Can't be 7 or 9 by the dot. So it is a 4. Well, that's a good point from Sayori, is that by Sudoku, you have a 2 on this 2, 6 dots. So you cannot have a 6. So, and you can't have a 6 here. So there is a 6 on this dot, for what that's worth. I'm not yet worried about making the orange line wrong, but it is a note that it's correct. 15 diagonal. Sorry, Garian row 4, column 1. Can't be 1. Can't be 2. 3. 3, we have to worry about this. 9, 12, so it can't be 3 by the little killer. I would not have seen that. Thank you, Garian. 4, it can be not 5, not 6, not 7, and not 8 by the white dot. So it is a 4. Nicely spotted, Garian. Sometimes I do just love these little case checking things. Sayori really wants us to look at the 3. Right, can't go with the 6, so the 3 goes here. Yes. Right, 2 is in one of these. Good point to people. 3 and 9 in box 2. 3 and 9 can't go here. They can't both go in these cells, so this is 3 or 9, but we need to make the thermo wrong, so that's 3. People want these to be pairs. Let's see, no 6 over here, no 1 over here. Yes, 9 is now on the thermo, so it's in one of these cells. Our 26 diagonal is relevant. So 9 plus 4 is 13, 16, 20. So this can't be a 6. So it's an 8. Thank you. Martin says this is naked. Ooh, I got caught. 9 can be at the end of the thermo if the others are in the wrong order. Thank you, Ilm. So, let's see. This can't be 1. Could be 2. Can't be 3, 4. Can't be 5. Can't be 6. Can't be 7, 8. So this is a 2 or a 9. Hi, Mehdi. Jay wants these marked, which we can do. No 1, 2 here. No 5 here. Yeah, Mehdi points out one of these is 1. Sayori pointing out this is an X, so this can't be 7, otherwise we'd have a true X. See, what can this be? Not very many things. It can't be 1 or 2 by the whisper. Uh, can't be 3, 4. Could be 5. Can't be 6, 7, 8, or 9. So it is a 5. And now we... Oh. Well, that's silly. Yes, it's not 5. Okay. Let's mark this one up. Could be 1, 2, not 3, not 4, not 5, not 6, not 7, not 8, or 9. So, what is the thing? Oh, this is a naked single? Uh, ah, it, let me make sure. So it's not 1 by the thermo, not 2, not 3, not 4, not 5, not 6, not 7, not 8. Ah, so it's just a 9. So that's the 2. 6 can't go here with the 1. Excuse me. 6 can't go here with the 1, so it must go here. Was this wrong? Ah, that's it. That's it. Uh, this can't be 1, 9. You have to put the 9 somewhere. And if this is 1, then either you're going to make the X correct or you're going to make the thermo correct. So we were right. We just hadn't quite justified it. So that is justifiably a 9 and a 2 and a 6. Yeah, we still have 3 digits to place here. These can't be a 3-7 pair, so that's 3 or 7, and it's not 3 by the diagonal, so that's 7. We have a 1-5 pair that's resolved by the white dot. Thank you. And let's see. This can't be 4-9, so this is 4 or 9. Kyle, it wasn't that it couldn't have been a 5, but we needed somewhere to put the 6. And this was the only place for it. No, hang on. Have to separate 4 and 5, so that is the 9 and 4 and 5. And this one is definitely 5 away from 9, so this one can't be. So this is not 5, could be 6, not 7. So this is a 6 or 8 only. Two, 6, 8 here, but this isn't 2 or 8, so that's 6, that's 8, that's 2. Yep. Nice. I want some ice cream. 18 diagonal. This can't be a 1, so it's 3 and 1. Thank you to many in chat. So let's just like massively pencil this row. Let's see, this can't be a 6. Row 5, column 2. We have a little killer that needs to not add up. And so 15, 29, 31. So this isn't a 1, it's a 2. It's a 1, and now this is 1 and 3. This can't be 4, and this is 1 and 6, so this can't be 7. So it's a 6 only. Now this can't be a 3, so it's a 1. That's a 4. That's a 7. That's not a 2 or an 8. That's not a 2. 7 cage, thank you. So that's a 5 and a 3. Yes, Sarah points out that these two cells are the only places for 6 in row 4. So we certainly can't have a 3 in these cells either. If this is a 6, that can't be a 2. So now one of these is the 3, which will have Right, one of these is 6, so this certainly can't be 2. Now 2 is on this white dot, so we can't have a 1 or a 3. So this is actually 2 and 8. This is 3. This is still not 5. Let's see. No 8 here. That's a 6 and a 1. Uh, 6 in box 5. Ah, goes here by Sudoku, of all things. And 4 in row 5. Not there, and not there by these X and V's. That's cute. So that's a 4. Yes, we have to make sure these don't add up to 41. A 1 by Sudoku goes here. So that means 9 must go here. Let's see. Not 1, 2, 3. Oh, wait, it could be 2. 4, 5, 6. Not 7, 8, or 9. It's 2. So that's an 8, that's a 2, and this is a something. 1, 2, 3, 4, 5, 6, a 7. Ah, 4 by a combination of Sudoku and black dot goes here. Thank you, Martin and Sayori. Screaming Ice Cube says we could just finish the column. We can. Let's see. What are these? They're things. Oh, 6 in row 8. Goes here. Ah, that's a 4. Naked 4. So we get a 9 there. 7 and 3. There are 4 4s looking into box 9. Is that our last 4? Yeah. Column 9 needs a 2 and a 3, and this black dot resolves it. Let's get these going. Naked single there. see. What else do we have? Oh, column 7, we have a 5-8 pair. So that's a 1 and a 9. Thank you, Nikolai. Oh, and we have a 2-5-8 pair here. So that's a 7. That's an 8. That's a 1. That's whatever's left in the row, a 7. Are we gonna have to start looking at this Dutch Whisper? Yeah. So 3, 8, 1, 6, 2, 6, 2, 7, 3. So we could break it here with a 5. We could break it here with an 8. Does that do the same thing? Or we could break it here with a 2. If this is a 2, that's gonna screw. Or 7 column 3. C is both. If we don't break it in one places, we don't break it in all places. That's probably true. So if that's an 8, sorry, if that's a 2, we go 8, 5, 8, 2, 5, and it's correct in all places. So we have to break it. So that's an 8, that's a 2, that's a 5, that's a 2, that's an 8, 5, 8, and the bet tree is 5. It was a cool end. Realizing that you had to break it in all 3 of these places, so you didn't break it in any. So let's see, 5. Again, I'm so skeptical of all you folks. But divide your 2,000 points, you massive number of 5 betters. Yeah, that was a lot of fun. All right. I am going to I'm going to take a quick break and come back with another puzzle. So I will see you all shortly. Welcome back. I am now refreshed. I think I saw Sergey in the chat. I thought we would take on a little bit of a challenge. So here we have normal Sudoku rules, normal killer rules. So the cells in boxes sum up to the total given. And then we have between lines where digits along a line are strictly between, thank you, are strictly between the digits in the circles. Yeah, I'm fixing it now. Do. And can embiggen the tris a little. There we go. All right. And knowing ZegreS, this is this is going to have kind of a tricky break-in. Now, Danzor has a good point. Oh, row 9, column 5 for Betzel. Thank you. Thank you, Sergey. So 9 in this row can't go in a 7 cage, and 1 and 9 can never go on a line. So 9 goes in one of these cells. Oh, it does look like the Zeta break-in. So where does this digit go in box 5? It goes up here. This does look like the Zeta break-in. So this green can't go on its own between line, can't go on its row. So green goes in one of these cells. But blue can't go on its own between, so blue goes in one of these cells, and we have to figure out what that means. Actually, I'm not sure that means a lot. Although we do get 1 and 9 in these cells. Yeah, and blue is in the 7 cage. That's a good point. So blue is blue is limited-ish. Row 6, column 3 can't be 9. So whatever this is, it's more extreme from blue than green. So like if this were a 2, this would have to be a 1. For row 6, column 3 is... Okay. 5, column 3, and row 5, column 7 can't both be the low end. Hmm. Oh. Yes. I think. Ooh. If row 6, column 3 is 9. And this is a 5, and this needs to be less than 5. So these would both be the low end. So the problem with this being the low end... I don't understand the problem, because if this is a 9, then this is a 9. And what's the issue? Oh, okay, so we have to think about these lines, because whichever of these is lower... Yeah, Carl is right. Whichever of these is lower, these both go on lines. So whichever of them is lower just definitionally goes on a line. Uh, but right. So then if green is the low end, blue must be the high end. Yeah, J40 is right. If these are the same digit, then you get the same highness lowness. So this digit, well, yeah, so if this is a 9, then this is the low end, and this is going to be lower than that. And but that breaks this line. So this is certainly not a 9. And if this is a 1, does the same thing happen if this is a 1? I don't think so. That's a little weird, but true. Well, wait. Have I convinced myself this can't be a 1? If that's a 1, then it's the low end. This is the high end. But low end, high end. I don't immediately see the problem with this being a 1. Because that still does get us green is the high end and blue is the low end. So that doesn't break the thing we had before. So it's possible this can't be a 1, but we can't reuse the same argument. Garion says if this is the low end of that line, then you get a 7, 8, 9 triple in row 4 in box 4. And that breaks the 13 cage. Yes. As if this is the low end, then 7, 8, 9 can only go here in the row. So this is the high end, which means it's at least 6. Right, and this can't be as high as 6 anymore. So this can't have... So the blue in here is not 1 or 6, so this isn't a 1-6 cage. So it's a 2-5 cage or a 3-4 cage. And now if this is a 1, you can't put a 1 in box 6. So this is not a 1. So 1 in row 4 can only go here. I buy that. So now we get to bring out Zach for a 1 dance. Do 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 wee do 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 woo do 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 wah do 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 wee do. Thank you, Zach. All right, so if this is 6, then that's 3, 4, 5. And we've ruined the 7 cage. So that's not 6. This 1, if we look at where 1 can go, it must now go in one of these circles. because it can't go in a 12 cage. Glob glog blog says, now where do we put 9 in row 4? It must go here. We've argued this can't be 1, so 2 can't go on a line. So this is just a 1, 2, 9 triple, points out Wrogn. So this has to be lower than blue, right? Is that what we said? Yeah, I guess I was just about to rule 2 out of there. So and it can't be 1. So this is only 2, 3, or 4. Ah, we have to put a 3 into box 5, which means we're going to need a 1 or a 2 in a circle, and it can't be that one. So it's going to have to be that one, so that we can put 3 on this line. And 8 is going to have to go up here. Two in row 4. Not here, not on this line. So this is a 2, 5 cage. So blue is going to have to be 5. So this is 6, 7, 8. So I think we can, and this is just 3, 4, 5. Okay, I think we can uncolor for now. So yeah, this is 6, 7, or 8. I agree with chat. And let's see. We need a 3 and a 4 here. So that's going to make this 6, 7. So this is a pair as well. 2, 3, 4, 5, 6. This is an 8, 9 pair. Uh, it is pointed out I do know the order of this since this 129 looks left. So that's 8, that's 9, that's not 8. Now we have a 6-7 pair in the row. So this is a pair as well. 1, 2, we need a 3. That's a 3-4 pair. It's a good point from who said it? Carl. What is the lowest we can make this? If we yeah, this is perfect. If we minimize this, this is a 3-6 pair. Uh but there must be a 6. So these are from 3, 4, 6. But there is a 6, and now this can only be a 1-7 pair. Yeah, virtual 3, 4 pair. Yeah, I agree. This is 3, 9 or 4, 8, and that's the low one. And that's the high one. So this is a triple, which we might as well write in. Let's see. 1's gone, 7's gone, 3's gone, 4's gone. I did that wrong. No, that's right. It seems hard for this to be a middling digit. Oh, uh, yeah, that's right. And this can't be a lot of things. It can't be a 1. It can't be a 9. And if it was an 8, we'd have to put a 9 there and we'd break that cell. So that is a 7. I agree with Martin. Oh, yeah, that can't be a 1. So that is a 1. Good point. Good point to many of you. Now we have to place 1 in box 9. That's a great point to Garion. I agree with Nicholas that this can't be a 6. Oh, yeah. No 2 there. Sorry, I kept seeing row 8, column 2 can't be 2, and I was like, what? But no, this certainly can't be 2. Let's see here. 2 and 9 definitely go in these cells. Of course, this one's not the 9. So that 2 looks left, and now we get a 5-6 pair. So that is a 2. Hi, Nell. How are you doing? Yeah, Eckbert, 1 and 2 in row 7 go here. So that's a 7 or a 6. Oh, a 9 in row 7. So I already, so we get a 9 there. So that's an 8. So we get a 9 and a 3 up here. It's a 4 and a 6, so that's a 3 and a 4. These are known. No 7, no 4, no 6. So these are a pair. Oh, they also are by the box. They are 3 and 4. Sarah points out we do have to put an 8 in row 7, and it's going to have to go in these cells, which means we need a 9 in a circle. So 9 is going to go there. This 14 cage is now known, points out Martin. So that's a 6-8 cage. Ah, 9 in box 3 now goes here. We definitely get a 9 in one of these cells. Nine in box 8. 9 in box 8. Very good. So that's a 9. That's a 9. Now we have our 9s. If this is 4-8, we have too many 4-6-8s in the row. So this is 5-7. Good point, Screaming Ice Cube. So that looks over here and resolves the 1 and the 7. That also gets us that for what that's worth. Yeah, 1 in row 3. Very good, Carl. Can't go here because of the pair. So it goes there. Now 2. Well, 2 could still go in either of these places. Yeah, this can't be too big. I don't even know if this can be 4. I I don't think you can make 4 work. Because you can't make any of these 7. 8, 6, 4. That's a good point. Yeah, if this is 4, you can't put a 3 in row 2, so it's not 4. That's a much easier way of seeing it. Oh yeah, 2. I I just said 1 can't go up here, but 2 can't either. So 2 in this row does go over here. So we get 8 and 5. Get our 6 and our 8, our 4 and our 6. Jennifer points out that 1 in box 6 is placed. These are from 6, 7, 8. I think I did that right. So that one's naked. So we get these. That resolves this cage. Our other 2, 3, if we just finish this row, so we get 2 and 3 like that. No 3 there. That places our 2 here. 5 and 2. These are from 3, 4, 5. Yeah, if this is not 3, you can't put a 3 in the box. So that resolves that. Yeah, we get our 3 there, 3 there. Resolves the 8 cage. 4 or 5 pair looks up. 4 or 5 pair does look up. 7 in row 9 has to go in one of these cells. So that's a 6 and a 2 and a 1 and a 2 and a 1. Now that we know 7 goes here, 7 has to go here. And so 7 has to go here. This has been a great puzzle, Sergey. With a very Zeta-like break-in. Yeah, it might just be time to mark. Because we're going to get a lot of stuff. 5, 8, 3 and 4 and 5. 1 and 6 and 2. 4 here. 5, 4, 8, 4. 7, 5, 7, 8, 6. 8, 5, and the bet tree is a 7. Great puzzle, Sergey. Yeah, the break-in was really fun to puzzle out. Poor Ranks. Bet trees are never 8. Hi, Dorlir. Welcome. Well, that was a lot of fun. I am going to grab myself a glass of water, and I will be right back. See you shortly. right. Let's see. Let's see what we've got. See, Dorlir just came in. We could do a Dorlir. Let's do a Dorlir. We have 6 whispers and 1 dot, which here we go. Let me add this to the thing. My words have departed. I will fix the rules capture in just a second. Is Dorlir still here? Okay. Check OBS. Yeah. We have a recommended bet sell from Nell. Looks good to me. We will be betting on row 4, column 3. Okay, so we just have German whispers where adjacent digits along a line. Oh, row 4, column 3, sorry. We have let's see, has anyone actually bet? No one's bet. Wait a second. No. We're not doing that. I got the joke. A little too late. We will put the bet tree down here. So let's try that again. But as has been mentioned, we do get a given 5, which I will even make green for Casey, and we get to do a 5 dance. Do 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 do. Ooh. Do 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 do. Wee. Do 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 do. Do 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 do. Wee. Let's see. We are going to need to put 4 and 6 into this box. Oh, could we put one here? Huh, maybe. Oh. Well, no one needs to see the puzzle. I will just I'll just describe. Yeah, so let's see. uh, so I was gonna say that this had to be a 4 or a 6. So we can't put them both in here, but I don't know if we couldn't put a 4 or 6 here. Oh. Carl wants us to color the longest line. That could be fruitful. So all of these are one color. Uh, so yeah, I agree this isn't a 4. So I guess 4 does have to go in one of these, but let's see. Carl wants us, so see if this is not 4 6. Yeah, that's the point. Even if this was 4 6, but then that prevents you from putting the other 4 6 in the column still. So this is a 4 6. So that's a 1 9. Row 3, column 5, and row 7, column 5 have the same color. Yes. Uh, and it can't be purple. So if it's purple, it's all the purples in the column. Wait. Row 4, column 5 is the same color? So, well, okay. Right. It breaks if this is purple. Because then these are both yellow, and now this isn't. This sees all yellows, all purples, and 5, so it can be nothing. So this color is actually yellow. You just have to extend the coloring a bit, and then you break that cell. So these are all yellow, therefore. And the rest of the lines, or the rest of the cells on this line are purple. Welcome back, Dorlir. So, does that give us anything uninteresting? Right, one of these is going to be purple, so this is certainly yellow. Yeah, one of these is yellow, so everything else in the box is purple. So that gives the coloring of these lines. So these are yellow and these are purple. We're out of purples in column 4, and that's a great point. So that's yellow, that's purple, and that's yellow. Now we have one low and one high in these cells. Yep, dot is not 1, 2, or 2, 4. So it is 3, 6, or 4, 8. All purples done in row 6. Great. So that's yellow. Purple, purple, yellow. And that's all of our lines colored. Ah, great point is that this can't be a 4 or a 6 because, well, I mean, we already have the purple 4, 6 in the box. So, so this is 3, 8. This is 4, 6. So that's the other 1, 9. This sees all purples. How do we know it's yellow and not 5? Ah, that's it. Egbert points out we can't put 2 yellows in row 5, so that is yellow. And this is a 5 in the last yellow, so that makes this purple. So that's going to, no, that's going to be a 5. Purple 4, 6 in box 5. Wow. No matter which... Well, that's not 4-6, but wherever purple 4-6 goes, and it's in one of these, I think, this one is always yellow 1-9. Uh, we already have all yellows in box 8. So yellow 1-9 is placed. Thank you, Sayori. Uh, doesn't it? Because uh, if this is purple 4-6, then these are yellow 1-9 and they look into box 5. So that one's always yellow 1-9. It doesn't matter where you put purple 4-6 in box 5. It always makes this one yellow 1-9 because of the geometry of this line. Oh, we have to put a yellow 1-9 in box 4. It goes here. This is a 2-7. We have all the other purples. That's a yellow 1-9 now. Yellow 1-9 in column 5. Yep. Need to put a yellow 4-6 into row 6. Could go here. Could go here if that's a purple 1-9. Hmm. These aren't 4-6, so they are 2-7 and 3-8. So this is going to have a 2-7 next to it. Or no, this is going to have a 3-8 next to it. Why not 3-8 here? 3:3. Ah, yeah, this is yellow 3-8. Very good. Three eight? Where did I get 3-8? I've been doing these wrong. It's 2-8 and 3-7. I've been doing this wrong the whole and yeah, this one. Oh shoot. Ah! It's screwed up because of the dot. This is not good. The dot is really screwing with things. Purple 4-6 can't go here. Can't go here. Can't go here. So this one is purple 4-6. Yeah, this one is 1-9 or 2-8. Purple 4-6. And box 7. Oh. Oh, it just must go in the corner. I see. Now we need to put one of these in column 3. It's gonna have to go here. Good. In row 1, it's gonna have to go up here. So we'll also need it in one of these cells. It's already in column 4. Good. So that is now purple 4-6. Good. Dropped a few frames. I'm not dropping frames now. Looks okay from here. Okay. Yeah, I dropped a few frames for just a minute and then it came back, so fingers crossed. Okay, so yeah, one of these is 4-6, and one of these is purple 4-6. So we're gonna have to put purple 4-6 here. Right, this is our last yellow. How are we gonna get a handle on things that aren't 1-9 or 4-6? Yellow 4-6 in column 3, huh? Right. Goes here. Let's see, yellow 4-6 could go here. Do we really want to talk about purple 2-7? It seems horrific. Are we really doing 2-7-3-8? That seems like it just blows up. Trying to do German whispers logic. I don't want to mark things as 2-7 or 3-8. I don't know, maybe we should. It's like, do we do enough Sudoku? But then how do you do any logic with German whispers if Look, if Dorlir says trust in magic, okay. Or column 2 is 3. Then you'd have to put 8 in row 3, column 3. Eight, I agree. Why couldn't you put an 8 here? Oh, row 6, column 4 would also be... that's it. That's it. It is not a 2, ranks. We, purple and yellow are on opposite sides of 5. But Garion has it that if we put a 3 here, that makes that an 8, but that's a 3 and that's an 8, and yeah. So we can go ahead and fill in digits. So that'll be a 7. That's a 9. Six, 6, 6. 1, 1, 1, 1, 6, 6. Right, now that's an 8. There's 7 and 9. Do we need to go back? Yeah, these were always the same. And we have to make sure these weren't the same. So it broke if it was too close to 5. That solves that. So that'll have to be a 9 and a 7. That's a 2. Three in box 5. Goes in one of these. So that's not a 3. It's not a 1, so it's a 2. Yep. These are 3, 4. These are 2, 5. That's an 8, 9, so that's a 7. That's her other 3, 4. Yes, we need a 7. Column 4. Oh, we only have one more purple. So that is the 7. Seven, column 5. Ah, this is 3 or 4. That's the point. So this can't be 7. So our purple 7 actually goes here, and that's a green 5. It's the other 3, 4. 8, 9 pair there. Now that's our yellow 2. That's our green 5. Now we need a 5 here. Our 3 and our 2 go in. So that's a 4 and a 9 and an 8 and a 3. 8 there. 4 goes here, and 9 goes here. Yep, this sees everything but 7. So that has to be a 1. So 2 or a 3. This sees 6, 7, and 9, so it's an 8. So that's gonna what? No, that's gonna have to be 9. Yeah. 9, 4 there. Seven, 8. Okay. It's possible we should. Oh, yeah, no 4 there. We do have an 8 here. So that's a 7. So these will have to be 2s. And now I think we probably mark. How about these? Yeah. Yeah, we get a ton. 439. Da-da. 5, 2, 7, 8. 5, 3, 7, 2. 4, 3, 4, 3. 6, 4. 8, 1, 6, 4, 9, 8, 1. And now we need to color. So lows are yellow. And highs are purple. And fives are green. And we need another purple, and it is a 9. Again, so close to ranks. Yes, GG. Good puzzle. Fun geometry stuff going on. The numbers the black dot was doing, and then the numbers from the German whispers confused me, but chat helped me figure it out. So now my betting thing broke. There we go. Yeah, great puzzle. See, do I need a break? I don't need a break. Let's just press on. And goodbye to anyone who is going off to watch Simon and Mark. We are going to do this Marty Sears Fog of War counting cages thing, which also has a lot of, so I assume I'm hitting up another one that's been on Cracking the Cryptic, but oh, today? Well, that's funny, but we'll do it, you know. Why not? All right. I don't think it should take us very long. No bet tree? Sure. Okay. I'll tell you what. I will pick. I'm going to pick a random cell and keep it secret. Okay. I have picked a random cell. I'm not going to tell you what it is, but it is fixed. It's not going to change. So you can go ahead and bet on my random cell. I just won't tell you what it is beforehand. So you can still bet, even if you've done the puzzle. All right. Uh, okay, so normal Sudoku rules. 4 yellow killer cages are hiding in the fog. Digits in a killer cage sum to the small number in the top left corner of that cage. Digits can repeat within a cage. In fact, a digit in a cage indicates exactly how many times that digit appears in that cage. A 5 in a cage means that there are 5 fives in that cage. Gray lines are bulbless thermometers. Digits along a gray line must be arranged in ascending order from one end to the other. White dots connect to consecutive digits. All right. Now, are we guaranteed that every cage has a given total? Because if it does, this cage has to get into hey Marty, glad you could make it. And congratulations on your assignment feature. Good night, Nicholas. Uh okay, so ah ah right. I see the logic. This makes a wall. That's the point. So this cage cannot leave this area. And in fact, because of this shape, it can't get to that cell. Um, and so the maximum times something could repeat in a cage is uh 3. Yeah, there are at least 2 cells in the cage. So uh we'll think about it carefully, but naively this is a 1, 2, or 3. Now if this is a 1, that breaks because uh there's more than one cell in here. Right, we've already ruled out 3 because we know this cell isn't. Wait, sorry. Uh, no. Okay, this can't be a 1 because then there can't be any more 1s in this cell, and uh, it can't get out of this box soon enough to only have 2s. So 1 definitely breaks. Now, 3, if this were a 3, uh, yeah, you can't. you need to get down to here, but there just aren't enough numbers to get that far. Right, this would need at least 4 cells in box 3, but we certainly can't have 4 different numbers. So that is a 2. And we get to do a 2 dance. Oh, Zach keeps running away today. Woo! Wee! Thank you, Zach. All right. So we know how this cage finishes. We need another 2, and it can only go here, and that's a 1. Marty, even you can bet, because I have a secret selected bet cell. Yeah, so if you look up above, it's exclamation mark bet, and then the number you want to bet on, and then the number of points you want to bet. And you can check your points by doing exclamation mark points. And now I'm warm. Okay. So, right. So cages are always a sum of squares, which is a great observation to make. And 29, if we try to do 25 plus 4, that means we only have 5s and 2s in here. But we can't even have a 2 in this box, so that doesn't work. So this is going to have to be 2 squared plus 3 squared plus 4 squared. So these are going to be 3 and 4. So that's going to make this one a 2. And now these are 3 and 4. So these are both in. We still need another 2. Still, this white dot is going to help, because if this is 3, this can't be 2 or 4, so this is 4, and the only thing this can now be is 5. So that's 3. This is going to be our extra digit. We need 4 in 4 boxes, so that's a 4. 3 and 4 go in. This is going to have to be a 3. And now this is a 4 and a 2. This is great. Now these are 2, 3, and 4. That's not 2. Yeah, this is really fun. Yeah. Oh, that's interesting. If this is not the top left corner of this cage, what on earth does that mean? Oh, is that going to have to wrap around all the way up to here? Since this goes right, we need something above it to be in the same cage, and this is the only one. So this is going to be pretty big. Sure, I can place the bet tree now. Betting is closed, right? Yep. My randomly picked cell was row 9, column 8. Right. If we minimize these, it's 1, 5, 6, 7. And that's all it can be. Because as Garion says, it can't reach boxes 2 and 3. Uh, so these are 1, 5, 6, 7. That one's going to have to be a 7. 131 cage. Now we need a 7 in this box. 2 in box 1. So So 1 squared plus 5 squared plus 6 squared plus 7 squared is only 111. So uh, we need another 20, which probably means 2 squared plus 4 squared. So there's a 1 in here. So these are from 2, 4, 5, 6, 7. And so is this one. Right, and it doesn't have... Ah, the 7 in every box except these two has to be part of this cage. So that is a 7. That's a great point to Garion. And there's no 3 in this cage. So that's a 4. And there's still no 3 in this cage, so that's a 2. So these are from 5, 6. These are also 5, 6. Oh, sorry. No, this one needs a 7. I was wrong. Yeah, that 5, 6 means that's going to have to be a 1. It needs a 6. And now everything needs a 5 as well. And how are we going to get enough 4s? It's going to have to go into box 9. So that's going to have to be a 4, isn't it? I think that's going to have to be a 4. Otherwise, we don't get enough 4s in this cage. Yeah, so 2, 4, 5, 6, 7. That's not 4 or 5. Now we go to 5, 6, 7 triple. That's it. So that's going to have to be a 2. Sayori points out that we get a 1 here by Sudoku. It's another 5, 6, 7. 4, 5, or 6. Kurban, the lines are directionless thermometers, so they go in one direction or the other. We have to determine. Okay. Let's see. What's left in this box? 8 and 9. One in box 5. And then just a pair left over. 8 and 9 there. 8, 9 here. So this thermometer is going to do it since this is high. Now this has to be the low end, so that's not 7, and that's not 5, but now we get a 5, 6 pair, so that's 7. Oops, 7. Five, 6 pair here as well, so that's 7. We go. Now this is going to have to be an 8 and a 9 in that order, which resolves all of this nonsense. Let's see. 1, 2. This can just be 5. Let's see, how many 6s have we got? 1, 2, 3, 4. And 5s. 1, 2, 3. Yeah. So these are 5, 6, 7. No, I already have a 5. 4, 6, 7. 7. Ugh. So these had better be 6 and 7 by the white dot. That's 4. 5, 6 pair here, so that had better be 4. What's this? 1, 3 pair? We know the order? Let's mark this box. That's an 8. Let's mark these. And these. Okay. Box 7 might be fruitful. Let's see. Let's see there. That one's just a 1. That's a 3. That's a 2. That's a 9, and that's an 8. Let's mark the top of these. We get a 3 there, 9. DT doot. 8 here. 1. Over here. 9 pair. So what's this? 3. And this is 2. And now let's see everything else. Ah, we are informed that. Haha, that's cute. I wouldn't have thought of that to Vish. It's like it is given in the rules that there are 4 cages, and we only have 1, 2, 3. So the 4th one has to be here and has to be a uh single 1 cage. That's very, very cute and easy to miss. So that can't be a 9 anymore. So now that'd be 6 and 8 and 9, and I think that's going to do it for the puzzle. 4, 3, 6, 7, 6, 5, 5, 6, 6, 5, 6, 5, 7, and the bet tree is a 6. Oh yeah, I was gonna completely forget. That was a really neat idea. Let's see. We did get a few 6-betters. All right. I think Marty is possibly the first person to win the bet on their own puzzle. Congrats, Marty, and thanks for the great puzzle. And I know I'm second to the party on solving this today, but it was a lot of fun. All right, I am going to take another little break, but we have more time. So I don't think we have to go to 6x6s. I'm going to take a break and then come back with another 9x9. See you soon. let us see. What have we got? Nell, are you still here? Uh, I think I'm going to do the index battle, Nell's new puzzle. Let's see. Get some links in the house. This looks like a fun hybrid. Oh, whoops. And I'm out of space already in the stream description. I blame James Sinclair with the incredibly long rules for his puzzle. All right. I don't see Nell still here. I am going to make sure that they know. Okay. Welcome back, Nell. Okay, let's have a look. Let's have a look at this. Row 8, column 5 for bet tree. If you want to bet star, bet other. That is the secret word. So let's get the betting going. Okay, every row, column, and box. Now, Nell, for answer check, do we just not fill in digits where there are stars? Or do we fill in zeros, or what is that? How does that work? There is no answer check. Okay. All right, so every row, column, and box contains the digits 1 to 7 plus 2 stars. Stars cannot touch other stars orthogonally or diagonally. Digits in columns 1 through 7 give the positions of the digits 1 through 7 respectively in their rows. For instance, if row 1, column 3 is a 5, row 1, column 5 must be a 3. But if it's a star, 3 can go anywhere. Renban are a set of non-repeating consecutive digits in any order and cannot contain stars. Ranks, if you want to bet on star, bet on other. That is our... Okay. Let's see. Well, since Renban can't contain stars, and in Star Battle, you have this whole uh, thing uh, where only one star can go in any 2I2. So one star can go in these cells. No stars can go in these cells. So we must have a star here. And we do a star dance. Boo-doo-boo-boo. Boo-doo-doo-doo-doo-doo. Wee. Ah! Ah! Penguin down! Ah! Zack attack. Boo-doo-doo-doo-doo-doo-doo. Wee. Doo-doo-doo. All right. Well, that was not the world's most successful dance, but it is our first star. Now, is it true that we can only have one star in the red cells in a row? No, that can't possibly be true. But there is some uh no, it's self-indexing cells that make that work. As I was like, I was thinking otherwise all the cells have to be in pairs, but that's not true if a cell is self-indexing. So uh so 1, 2, 3, 4, 5. Three, four, five, six. So yeah, 3, 4, and 5 on the Renbon. Ah, I agree with chat that a 6 in a red cell would put a digit here, but there is no digit there. So there is definitely a 6 over here. I hate to break it to you, Jennifer, there are no 9s in this puzzle. Okay, so where do we go from here? Welcome, Music Huber. Row 4, column 5, 6 is a star. How do we know row 5, column 5 isn't the star? I can mark a lot of cells as not having stars. That is true. Is that even visible? Can we see that? Should I make that darker? I should make that darker. Yeah. We do know row 5, column 5 isn't a star. And Renbons are automatically X'd. So there is definitely a star in one of these cells, which we'll mark with an X here, is that there's a star in one of these cells. If that is acceptable notation. I'll tell you what, we'll make it a line. There's a star in one of these cells. Uh, we can't put 5 in a place that should be indexed by a 4 that is not on the Renban in box 5. Centers of boxes are never stars. That's a great point, Garion. As that would rule the second star out of the box. So I'm sorry to our other betters, of which there are multiple. If row 4 column by our earlier logic, the star here means there's a 6 over here, but a star here would mean the same thing. Vish is absolutely right. So we get our second star, and now we get to X all around that. I'm not going to bother Xing Renban. We'll just... Yes, now this certainly can't be a 5. And in fact, this is going to have to mean there's a 5 over here, right? This isn't a 5 because it would put a 4 off the Renban. That's a good point. Row 6, column 2, row 4, column 2, see a star in row 5. In fact, where is one of the stars in row 5? Why is that an X? Is that a legitimate X? Or did that just happen? Center of box. Right. So where is our... one of the stars in row 5 will be... Oh, they could both be over here. What am I saying? I was about to say that had to be a star, but it doesn't. But it is true that at least one of these is a star, and therefore these cannot be stars, as Sayori pointed out. Kyle points out that row 1, column 5 being a star would rule a second star out of box 2. So it's not a star. And now there is suddenly only one more place for a star in the column. So we get another 5 over here. Can't have... Okay, so... Glob says you can't have stars here and here. Yeah, in fact, stars can't be in the same column. in any box. You can't have both stars in the same column in any box, because then you would duplicate a digit over on the right side of the grid by our logic that we did at the very beginning. So only one of these can be a star, only one of these can be a star, but it must be 1 and 1. So that rules out all of these cells from being stars. Oh, right. I should do my Xing in box 8, because the second star is just placed. We get a 4 over here. And I can do my Xing from that star. Oh, and we still need 2 stars in row 8. And now we're going to get a digit, because where do we put the 7 in the row? Only here. So I think we should do a second dance for a digit. Whee! Second dance. Great. So, and let's see, we get to X the rest of this box. Row 1, column 6, or row 2, column 6 is a star. Yes, we need so that's going to rule out, yeah, it's going to rule out both of these, since one of these is a star, so that's a star. And so we're going to get a 7 here and a 5 here. And then we get Xing here, here, here. Now one of the stars for box 4 has to be here. Also at some point we got a 5 here. Row 6, column 1 is going to see one of the stars in row 7, points out Sayori. So that's a star. And this has to be a 1-3 pair. So these aren't 3s. Okay. I wonder if it's going to have to be the case that that's a star. Row 1, column 3 sees a star in box 2. Right. We have this little wing on stars within this box. So this is never a star. We do have a star here in column 8. So that's a 6. None of those are stars. Yes, we get to do box logic now. We can put a star in these cells, no star anywhere else. So this is a star. So we get to X that cell. Get the other star in column 8. Oh yeah, I just do. So that is a star. That's not a star. Now only place for stars in row 2 now. There. So the rest of this box doesn't have stars. Ba, ba, ba. And now these are a 4-6 pair, and we know the order. So there's this 6 on a Renbon. Row 3, column 3 isn't a star. That is correct. Thank you. So now that's a star. That's not a star. And that, let's see. That became a 4. This now has to be a 3. So that's a 1 and a 3. Row 9 is done, points out Wrogn. Ron points out that these are a 1-2 pair. And we know the order, and that's huge. So that gives us these stars. And we'd better put a star up there. There. And that's all our stars. Cool. Now let's get rid of the X's. All right, well, let's see if this will work. Deselect those. Haha. Okay. Yes, we do get a 2 here. What am I doing? Right, we do need a 4 and a 5 on this line. Oh, we lost our bet tree. Does anybody remember where the bet tree was? There we go. Row 8, column 5. Uh, Okay. We need a 4. It's true, though entropies are a little weird. Uh, 5 column 6. If this is a 5, we need a 6 here. You end up with... Oh, that's true. I'm looking at 99% sneaky's point. If uh, this is a 5, you can't put a 6 and a 7 on the Renbon. That's a good corollary. So we roughly know where the 7s go. Yeah. Like one of these is a 7, one of these is a 7. Uh, these are 7s. Ah, there is a 7 on the Renbon. That is important. So this is 7, 6, 5, 4, 3. And now we can do some cleanup. 7, that's 3, 6, 6, 3. 7, I don't know where 9 came from there. Did I screw up what this could be? 7, 6, 5, 4, 3. Not 5 or 7. And 1, 2 left over. And we know the order. That is going to do a bunch of damage. So we get 7s here. 1 puts 6 here. Ah. Yeah, non-purples are not 7. That's a good point. 2 places 5. Yes. 5 goes here. 6, thank you. Ranks and glub, 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 glub. Let's see. And 7's up here go in these cells, but that's slightly less exciting. Oh, I can use entropy. Ah, so that can't be a 3. And that can't be a 4. Yes. This is 2 or 3. Let's see. We know one of these is 1. So if this is a 1, this can't be a 4. That's the point. In fact, this has to be a 5 or a 6. That's what I should have written down as soon as we had this pencil mark. So that must be a 1. Great spot, Sayori. So that's a 5. So that's not a 5. We need a 5 on the Renbon, and 5 here would rule 5 off the Renbon. So that's in fact a 6 and a 4 here. Why did I think a 3 could go on here? It's not. This is a 5-7 pair. Right, right. We don't know 7 goes on the Renbon. Right. So is this just a 3 or a 5 then? Well, it's not a 3. What is this? Not a 1, not a 2, certainly not a 3. Could be a 5 or a 7. So this one is 5 or a 7. Yeah, Chad agrees with me. Three placed in box 2. Well, one of these is 3, so we get 3 in one of these. And it can't be 5, so 3 is placed. I think I did that right, with a 6 here. 7. Uh, right. Right. 2 placed in box 2, so that's a 4. 2, 5, 7. It's not a 2, not a 7, not a 5. One, 2, 3, 4, 5, 6. Oh, this is just a 7. 2. So that's a 6. That's a 7. Great. Another great spot to Sayori. So that's a 6 and a 1. Five, 7 pair looks down, making that a 4 and a 5 and a 3 and a 4. That's a 2. 1, 3 pair. This 5 places a 6. Thank you, Vish. This is a write-in. It's 1, 2. This is a 3. So that's a 1 and a 3, a 1 and a, wait. No, that's fine. We just have 3, 5, 7 left in the row, but this can't be 3 or 5. So that's a 7. That's a 3. That's a 5. That's a 7. That's a 5. That's a 7. 3 and 2. And I think we're basically done here. Yeah, 4, 5, 1, 4, 1, 2. That's it. And the bet tree is a 3. Congratulations to our 3 bettors. Congratulations, Sarah. Apologies to our other bettors. That was a beautiful puzzle. I loved that. I think anytime you can mix Star Battle with other stuff, Star Battle mixes with things in such interesting and diverse ways that it's a great idea, and this was just beautifully executed. I like indexing, and this was a really novel indexing idea that you could do it to this extent with the stars. Loved it. Absolutely loved it. Okay, let's see. I really need to end on time today, so I have half an hour, so maybe I should just do 6x6s the rest of the stream. Just so we stay bite-sized. So I think I'm going to dive into the 6x6s. Jennifer's 9-bit was a root 9-bit. There you go. Uh, let's see. There's a Paul fly here I'm kind of terrified by. All right, this one's too cute. Have we really not done this one? Let me check the catalog. No? Apparently not. Okay. Uh I don't think I quite have enough time for uh the 6x6 that took you 2 hours in a notepad document. Let's do this little Chinese whispers puzzle by the Cogito. Yeah, it's a fun face. So all we get is that all we get is that normal 6x6 rules and red lines are Chinese whispers. So along a red line, digits differ by at most 2. Blob says that there's a 1 in one of these cells, but I don't understand why it couldn't go here with a 3. 1 in box 4. 1 in box 4 is interesting. So 1 in box 4 is definitely going to have to be able to get out of the box. Ah, yeah, I get it. 1 only goes next to 2 and 3. And so the 2's gone, so it had better go here with 2 in one of these cells, and there's a 3 in one of these cells. And I guess we could say there's a 2 in one of these cells, and a 3 in one of these cells. Hmm. Right, so this is next to a 3, and 2 and 1 are not available. So this is definitely a 4 or a 5. Ah, in fact, are we just going to get a 4 here? Because 2 can't have a 1 or a 3, so it's going to have a 4. And Eckbert, a couple of people saw it too. Uh, this is a 3. It can't have a 1, a 2, or a 4, so that's a 5. Good. So this is going to have to be a 3-6 pair, I think. Wait. No, I'm not. I'm no longer prepared to assert that. Uh, row 3, column 2 sees a 1 in its row. Ah, yeah. So it's also going to have to be a 4. Which makes this a 5. Hmm. Yeah, we can just... Oh, these are 1, 3, and 6. These are 1, 2, and 6. Ah, Vish points it out the way that I I get it. So one of these is going to be 1, 2. So therefore 5, 6 goes in the other one. So whichever one of these isn't 3 will see a 6 and a 3. So these are in fact a 3, 4 pair. I got it. I got it. So these are a 1. Uh, these are a 1, 6 pair. Right. I didn't say that quite right, I think. And so these are a 3 and a... So yeah, these are a 3 and a 4. Ah, yeah, yeah. There's a 6 here. So yeah, these are a 2 and a 5. So now we know what these are just by the row. They are 1 and 6. And by the box, these are 2 and 5. So the eyes, the square whisper lines either are the same or are mirrors of each other. The question is, where does 6 go in row 4? If it goes on the whisper, it can't be next to a 5 or a 4 by the row, and that just doesn't work. So that means this is a 6, and that's going to sort out a ton of stuff. Deet deet doot, deet deet doot. And that's a 1, 3 to go with. If this was a 1, this would have to be a 2 or a 3, and it can't be. Or a 1. But, so this is a 3, that's a 1. Now this is a 2 or a 3, so this can't be the 2, 1, 3 column. So this is 5, 6, 4, 3, 1, 2. So they turned out to be mirror images of each other. Oh, this could be 1, but the argument remains. Yeah. And these are 4 and 5 by the column. These are 2 and 3 by the column. That's not resolved yet. This certainly can't be a 6 next to a 1, 2, 3. This one's a 6 by Sudoku. So that'll have to be a 6. Now I think we mark and see what comes of it. Yeah. The only way this works is with a 2 and a 4. Very nice. Oh, that was a lot of fun, and what an adorable grid. I love it. There's a J. Dyer puzzle here that my eyes are crossing just reading the rules. I think I won't do that right now. Hmm. There's another J Dyer puzzle that I'm tempted on. Let's see. I don't really want to. I don't really want to do something dangerous. Hmm. Scrolling through, seeing what we've got. Ah, okay. Here's one. Let's do this. I might regret this, but okay, here's a math pesto. Da da da. Okay. So we have normal Sudoku rules apply. There is exactly one negator cell in each row, column, and box. Digits in a negator cell have their opposite value, so a 2 becomes a -2. Values on the blue line have the same sum in each box the line is in. Let's see, how are my outside the grid clues showing up? Fine, but I'll turn off uh, row and column labels. Ba, 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 ba. Uh, Values in the grid represent heights, with negators being underground. Numbers outside the grid indicate the amount of visible cells in that row and column as seen from that vantage point. So negators are seen if and only if they are adjacent to the edge of the grid. And a digit may be negated once, more than once, or not at all. Okay, well, okay, we have a single cell here that can be at most +6. So I think this can't be a negator cell. So we will gray it. And so can't really see that gray. There. Actually, that may be a little too dark now. Todd, no. Digits may be negated once, more than once, or not at all. So we don't. 2, 3, 4, 5. It's true. Carl points out that we have a 5-cell line. And even with a negated 6, the lowest value we can add to is 4. So this is from 4, 5, 6. One of these is going to have to be negated, so that's not negated. And one of these has to be negated, surely. So these aren't negated. A digit next to a 1 clue can't be negated. That's a good point from Nell. So this isn't negated either. It could be a 5 if the 6 is negated, but I guess these must be 5 or 6. Negations in box 5 must be on the line, yes. So no negations here. So let's see. We have to see 5 things in this row, which is an awful lot. Let's see. How would 4 work? Surely you'd still see either the 5 or the 6 after it. Negator in box 2 has to be 5 or 6. So if the negator was only 4, if the negator was 4, then you'd min at 1 plus 2 plus 3 plus 5, which is 11 minus 4 is 7, and that's too big. So yeah, the negator in this box is 5 or 6, along with this 5 or 6. So the sum can't be 6, we are told. Right, because we know 1, 2, 3, and 4 are positive, and we know they're on the line. And it's going to be minus 5 or 6. So it's 10 minus 5 or 6. So this can't be 6, which means as Vish and maybe others are saying there is a negator on here. So there's no negators here, which means we've located this box's negator. So none of these cells are negated. Yeah, we only see two, so we're definitely seeing this one. So this would be 5 or 6, and it's only 5 if this is 6. But it can't be 6 by the column, so that's great. So now we have a digit. That's 5, that's 6. Now we know this is a 6. No? I don't understand what chat is saying. This can't be 6. This has to be 5 or 6 by the 2 skyscraper. And if it's 5, that means we can't see the 6 after it. So we'd have to see a -6 before it, because we always see this cell. But by the 3 skyscraper, if this is 6, we can't see 3 cells. So this is 5. That is 6. And now that this is 5, we need to satisfy this 2 skyscraper, which means we can't see the 6 past it. So we must see it here. I think that's right. Chat uh chat shook me a bit, but uh ooh. Yeah, that is the negative heights apply to skyscrapers too. You can only see a negative digit if it's right next to the uh, clue. So this sum is -6 plus 5. Oh, I like Jim's point. The unnegated cells in row 4 must be in order. And this is unnegated, so it's 1 or 2. Sayori, the rules specify digits, negators can repeat, and not every digit has to be negated. Am I covering up the rules? I am covering the rules. I'm sorry. Garion doesn't think we can have a 6 on this at all. Or on... Oh, wait. Why can't this... So if this is a 6 as a negator, then we need to get up to 4 or 5. Right. We can't get high enough with 6 as a negator on this. So this can't be a 6 because, or could this be a 6? No, this can't be a 6. If it's not negated, it breaks this cell. If it is negated, it breaks the sum. So this is 6 and it's not negated. So we're at -1 here, so we need another 5 or 6 here. Well, we definitely need a negator here, so these aren't negated. 5 is placed in box 3. So if this had a negated 5, which would go here, then this would definitely be a 2. 6 minus 5. So this can't have a negated 5 either. And it can't have a positive 5 or you never get small enough. So I agree that that's now the 5. I agree with Jim. Garion points out that since we know 6 is not negated, it now goes over here. So that's a 5 now. So now we need a negated 6 in these cells. People are saying so the sum is 4. Right, we just said 5 can't be the negator here, so 5 is placed. So this is definitely a negator. So that rules out all this. This is a negated 6 to make this skyscraper clue work. Right. Because we know these are 1, 2, 3, 4. 10 minus 6 is 4. So now that should give us this. This must be a -1. And we have almost all our 6s. Last 6 goes here. So if we look at this, 2, 3, so that's a 4. 5 goes here. Uh, 2-3 pair looks up. Yep. Thermo in row 4. Right. Fives. Okay, now there's a 5 on this. So that surely is going to have to be negative. Yeah, if it's not negative, we... Right. So that's negative. And now we need 3 more. So that is a 1-2 pair. And they are not negated. That's not negated. That's not negated by the column. So that's negated. That's not negated. That's negated. So now we have placed all the negators. Right. This thermo logic, if you put a 2 here, you can't put a 3 and a 4 in the row. So that's 3. Three and 4 go here, and we know the order. That's 1 or 2. Ah, 4 in row 4 is now just negated. So so now that needs to be a 2 to add up. And I think that is just about going to do the puzzle. Let's see, does this add up correctly? No? What did I do? Where did I screw up? Box 1. So that's a 3, 4. Oh, I just placed a insane digit. 2, 1, 1. Okay, now we get to think about this and do actual math instead of putting random digits places. 6, sorry, so that's 0, so we need a 4, and that finishes the puzzle. Oh, that was beautiful. And we end on a dude. Well, I'm sorry about the very end trying to put wrong digits places, but that was awesome. That was lots and lots of fun. Um, all right. Well, I have a meeting at work in an hour, so I have to run away, eat dinner, and then head off to work. So thank you all for coming. It's been a lovely stream. We had some great puzzles, great fun. And Zeta Math will be back on Friday. I will talk to you all on on the Discord, and have fun. Thank you. Bye bye.